Have you ever looked at a map and noticed clusters of things, like certain types of businesses in one neighborhood or particular environmental conditions grouped together? Geographic Information Systems, or GIS, takes that observation to a powerful new level, revealing hidden connections and trends across space. GIS identifies spatial patterns by integrating diverse datasets with geographic locations, allowing it to visualize, analyze, and interpret relationships that might not be obvious in raw data. It effectively overlays information like population density, soil types, or crime incidents onto a digital map, then applies specialized algorithms to detect meaningful structures, clusters, and distributions. The core mechanism involves spatial analytical tools that mathematically assess proximity, density, and distribution. For instance, techniques like hotspot analysis determine statistically significant clusters where high or low values of an attribute are concentrated. Interpolation methods predict values in unmeasured areas based on surrounding sample points, revealing continuous patterns like temperature gradients. Furthermore, overlay analysis combines multiple layers of data to find areas where specific conditions co-occur, such as identifying prime locations for a new facility based on factors like accessibility and target demographics. To use GIS for identifying patterns, you first need to gather geographically referenced data, ensuring each piece of information has a location attribute, such as coordinates or an address. Next, you select the appropriate spatial analysis tool within the GIS software based on the type of pattern you are searching for. For example, if you want to find areas with a high concentration of disease outbreaks, you would use a clustering tool. Finally, you interpret the visual and statistical outputs, which often include maps color-coded by intensity or significance, allowing you to draw informed conclusions about the spatial relationships. A key concept here is spatial autocorrelation, which means that features closer together tend to be more alike than features further apart. GIS tools quantify this relationship, providing statistical proof of patterns rather than just visual intuition. This allows for rigorous hypothesis testing and moves beyond simple mapping to true geographical discovery. For instance, GIS can help identify not just where environmental pollution is high, but also statistically significant areas where it clusters, suggesting common sources or influences. Understanding how GIS identifies spatial patterns empowers us to move beyond simply seeing data on a map to truly comprehending the underlying geographical processes at play. This capability provides invaluable insights for urban planning, environmental conservation, public health, and business strategy, helping decision-makers worldwide make more data-driven and spatially intelligent choices for a better future.